अस्सलाम वालेकुम
वालेकुम अस्सलाम अब्दुल मालिक।
सर केड़ा हाल है
दुआऊं लगी पे शुक्र अल्लाह साईं।
सर LSPM टैक्स जनरेशन वारी असाइनमेंट जे लिहाज़ सां काफ़ी क्यूरीज हुयूं। हिकु त अचानक तव्हांजे वालिद साहब जी डेथ थी वई, इन ॻाल्हि असां क्यूरीज जेको न पुट बि कोन करे सघियासीं, तव्हां बिज़ी हुआ, असां चयोसीं मुनासिब बि न आहे,
सही
पोइ इन हिसाब सां उहे क्यूरीज थोड़ी पुछणी हुयूं।
बिल्कुल। अज सुनो, अजो का ये जेके 3 hours हैं, you know that we have already completed our course, so
जी
these 3 hours are 2 hours probably from 12 to 2. We'll be doing nothing, just answering your queries related to assignment, related to exam, I mean everything. So yes, don't worry, we will answer all your queries.
ओके सर, थैंक यू सर।
Thank Okay, so we are going to formally start. I think most of you are already here. Those who are still not available, we can make a recording available on LMS. So today we should have 2 to 3 hour interaction, and this interaction will mainly be interactive. I mean, we'll be discussing about final exam, and I will be answering queries related to course, related to your related to your assignments or any other aspect of the course. Just one thing, in previous class, I asked you guys to do a lot of practice of mathematical part of the course. Are you people doing that practice? How many of you have taken that suggestion seriously?
सर मैंने
यस
CNN की प्रैक्टिस कर ली है, CNN की
जी
काफ़ी
सर,
8 से
बिल्कुल
10
सर,
एग्जाम्पल
सीरियस हो
नेट
गए।
से लिए, उनकी प्रैक्टिस की है।
ठीक है, ठीक है। Shakil, how are you?
Yes sir, I'm doing practice with means I have started from the beginning. Just we have used probability and bias theorem, and I'm doing neural network mathematics as well.
Good, good. Dayanand?
नहीं सर, मैंने अभी तक नहीं की है।
Dayanand, you will have to come closer to your mic.
सर अभी तक मैंने इसकी प्रिपरेशन नहीं की है।
नहीं करें, you will have to do it. I mean, believe me, that exam will be a huge mountain to climb if you have not done enough practice, but that will be walk in the park if you have done enough practice, because it is mathematics. You know, unlike your mid exam when you had open book exam, this one will not be open book exam because it is final exam, and you know there is external involvement. So I want you guys to perform well, and I have already kind of discussed the paper format with you. It will be more mathematical than theoretical, because I do not want you people to write your rubbish, ugly looking English and external, deduct mark because your English is not very good. So that is the reason why most of the aspect of the final exam will be mathematical. I mean, if the external moderates, I'm not sure if he includes his own questions, which asks a lot of theory, But from my side, I've been more mathematical than theoretical. And when I say mathematical, you know what aspect of the course are mathematical, what aspect of the course are numerical. So you should be doing a lot of practice. I mean, CNN, simple neural network, a lot of other aspects of the course which were mathematical, you must be focusing on them. So let's start with a quick review of what we did throughout this semester. Uh, we started with introduction, what is data science, example from practical life, and then we had a crash course in Python, and I also recommended you Mosh. I hope many of
Sir,
you.
share screen. Please
Ah,
share
okay,
screen.
okay. Sorry. Thank you, Malik, for. Okay, share screen. That's it. Okay, I hope you can see my screen now.
Sir.
Can you see my screen?
Yes,
Yes,
sir.
sir.
Okay. So we started with introduction, what is data science, example from practical life, and a crash course in Python. So we started with this lecture. It is available on LMS, so you can download it. Data science. We discussed about why it is, what is data science and what is deep learning and all these things, right? uh, then we also discussed about importance of data science as a new oil refinery. I mean, Saudi Arabia is losing its charm, China is gaining, because China have got a lot of data. So your data is actually new oil resource. I mean, it is as important as oil in 20th century. So certainly, data, those countries which are going to play with data properly, they're going to take lead in 21st century. We also discussed Cambridge Analytica. I'm not sure how many of you have seen that Netflix documentary on Cambridge Analytica. I strongly recommend it.
सर 90% स्टूडेंट्स ने तो लाजमी देखी होगी, हमने तो देखी है.
Okay,
हाँ,
good.
एक दो होंगे शायद, बाकी हमने देखी है.
Good, very good. So that actually must have given you a kind of feel how important data is. I mean, come on, you can change, you can kind of manipulate American election, American superpower, world superpower. If you can, with the support of data, if you can manipulate American election, you can manipulate anything. I mean, then probably more than Trump, more than Putin, these data scientists are more powerful, because they know how to manipulate minds, and that is because of data. And a lot of new jobs are around, a lot of old jobs are dying because of this data science. So obviously, being a computer scientist, if you are not good at data science, it's better that you join a different career, because now playing with data for a computer scientist is really not an optional, it is absolutely mandatory. And for playing with the data science, you need to know probability, you need to know statistics, you need to know programming, you need to know calculus. All these are the ingredients of data science. And believe me, data science is not a whole new idea. It is actually based on those old ideas. I mean, even in 16th century, we had all these beautiful algorithms. Only in 21st century, we have started using them differently. And now we call it data science, a beautiful wrapper. Otherwise, everything that we learned in this class, probably you might have already covered in your probability and states course, or maybe in your calculus course. So overall, these mathematical things, they have been put in different way, and now we have given it a beautiful umbrella term. We call it data science. And thanks to Python, and thanks to 21st century technology like GPUs, cheaper storage, this data science has gained a lot of momentum. We discussed about this Brexit, about Russia, and then I also recommended you this one, social dilemma. Ah, wow. I mean, a must watch. Huh? These books, I'm not sure how many of you have gone through the fourth age, AI superpower, and Life 3.0. Shadid, have you read these?
Yes, sir.
Have you gone through any one of these three books?
Sir, I have read Life 3.0, but I haven't read those two, AI Superpower at the fourth age.
Okay, okay. So what is Life 1.0? What is Life 2.0? And what is Life 3.0?
Sir, actually, Life 1.0 was the primitive life that the man was living like in the Stone Age or any other very primitive technologies man knew about, like blowing the fire or anything else like these things. And the 2.0 was about like the industrial revolution that changed throughout the man about into the new era. And Life 3.0 is actually the era of artificial intelligence and machine learning that is also changing the history to the new era, the era we are living in. This is actually the Life 3.0.
Right, right, right. I think this is one way author has put it, but there is another perspective of author. I think he also said that Life 1.0, when we were simply, evolving, we
Yes,
had
sir.
no control on our bodies, we had no control on our mind, we had no control on bits and atoms. I mean, bits he call the software, the soft side of the human body, the brain, and the atom he call the body. So in Life 1.0, we really did not have any control how we are evolving. It was just natural selection that we were evolving. But in 2.0, we got better control of our body. I mean, even our mind at that time was not being controlled by outside force. We thought that mind is a black box, and human mind is a black box, so nobody can really manipulate it. I mean, that is the reason why democracy became a successful model, because they thought free will is there. They thought that people cannot manipulate your mind. So they say that in 2.0, we were able to, install a separate arm in a human body. We were able to transplant kidney. We were able to, play with our body. But playing with mind was still, not in our thoughts. We thought that this is black box and we must not play with it. But in Life 3.0, we are now able to not only play with your body, but also play with your mind. I mean, both soft side as well as a hard side. So hardware is your body, software is your mind. And in 21st century, in Life 3.0, we are able to, manipulate both. You can, you know, beautify not only your face, but you can also play with the genes so that you become a superhuman. So, Life 3.0 means you can play with soft side as well as hard side of human body. So that is the reason why they call it Life 3.0. So I'm sure if you read it more, you will enjoy it, because being human in the age of AI is really a funny thing. I also recommend that you should read The Catastrophe of Zuckerberg. They call it ZUCKED, ZUCKED. That's another book which I have recently completed. That book is also fantastic. I mean, that also tells how these, you know, uh, I don't want to call them crook, but the author is calling them crook. He says how these crooks are actually playing with humanity. So Zakt is actually should be on your reading list. So these three books actually give you how important data science is, and obviously these are my all-time favorite. If you just want to see how we have evolved from 1.4 billion years and how we have reached to 21st century, I mean, this whole history is in these three books. I hope that you have gone through these. Python basics, we did all this on machine. We covered list, we covered tuples, we covered dictionaries, we covered, you know, counter, control flow statement, sorting, you know, all these things we covered practically in class. And I also recommended you, you know, one of the 6-hour video, Mosh, the bald guy. Then we started discussing about data visualization. Again, we used Python for that. We understood, you know, all these control flow statement, all these things. And then we actually played with the matplotlib, in which we covered bar chart, histogram, scatter plot, stack plot, pie chart, and then we played with the COVID-19 tweet data set just to display it, how many of them are positive, how many of them are negative, how many of them are having different emotions, right? So we visualized this data set, and then after this we started, you know, algebra and probability, because these two are the building blocks in data science. So in linear algebra part and states part, we covered vectors and how vectors are implemented in Python. Vector sum, multiplication, mean, product, sum of square, you know, all these things we covered. And then we saw how matrices are working in Python, right? Shape of the matrices, all these different aspects of playing with the matrices. And this running example in the book, the connections, the friendship. So, you know, this one is a list in which we say 0 is friend of 1, 0 is also friend of 2, 1 is friend of 2, 1 is friend of 3, 2 is friend of 3, 3 is friend of 4, and so on. So same information which you see in form of tuple, I mean list of tuple, that can also be represented in form of matrix. So you can see in this matrix, this is user 0. So user 0 is friend of 1 as well as friend of 2. So this row is actually representing, this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So here, if you want to say that 0 is friend of 1, which means that this is the 0. This is the row for 0, right? So 0 is friend of 1. So 1 is here. So you can see this is turned 1, and those where connection is not existing, they are 0. So you can see, because 0 is friend of 1, so this one is turned 1. 0 is friend of 2, so this one is also turned 1. Everything else is 0, because 0 is not friend of 3, 0 is not friend of 4. That is the reason why all these things are 0. Right. So same information, it can be represented into this matrix form as well. This is probably more compact and very easy to play with. 1 is friend of 2, 1 is friend of 2. So you can see this is a row for 1. 1 is friend of 0. I mean, this one is turned 1, because 1 is friend of 0. That information we see from here, right? Although we do not see 1 and 0, but because 0 and 1 is there, so this one has to be turned 1, right? 1 cannot be friend of itself, right? So 1 is friend of 1 is 0, because that tuple is not here, and 1 is friend of 2 because of this, 1 is friend of 3 because of this, and then 1 is not friend of 4. So you can see 1 friend of 4 is not there, and 4 friend of 1 is also not there. That is the reason why this one is turned 0. Similarly, you know, if you see 7 is friend of 8, so this is 0, 0, 1, 2, 3, 4, 5, 6, 7, right? So 7 is friend of 8. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So you can see this one is turned 1, right? So same information, the list of tuple, you can represent it into matrix form. So this connection information can easily be represented as a list as well as a matrix. I mean, you know, different representations. You can play with any combination, whichever you are feeling more comfortable with. Right. We also did this to write code to generate, matrix for the following relationship, right? To convert this list into matrix. Then we thoroughly discussed about this example, the data scientist example, in which we actually did nothing, just converted, this list into this tuple. Because if you see that the ID 0 is for hero, ID 1 is for done, ID 2 is for Sue, ID 3 is for Chi, and so on, right? And when we see here, this relationship, it is same, written here, right? And if you create a kind of network diagram for them, so you can see same information is represented visually. Here 0 is friend of 1, so that is the reason why this age is there. 0 is friend of 2, that is the reason why this age is here. 0 is friend of 1, 0 is friend of 2, and 1 is friend of 2, 1 is friend of 2, that is the reason why this age is there. 1 is friend of 3, that is the reason why this age is there. And 2 is friend of 3, 2 is friend of 3, that is the reason why this age is there. Then 3 is friend of 4, 3 is friend of 4, that is the reason why this age is here. So you can see same information can be represented in different formats, in list format, in matrix format, and so on, right? This code we saw, we actually wanted that in this two-dimension array, we should have first dimension as index of the friend, right? 0, 1, 2 up to 9, and the second is friend. So a 0 friend, so all the friends should be listed here, right? So this is actually to convert that same tuple information into 2-dimension. So all these examples we have done in class. I strongly recommend that you understand them fully, and if possible also implement them, because these are highly important. These are very, very important. You must fully concentrate on these, right? And then these examples we saw programmatically. In states, we discussed about the histograms, uh, you know, all these different parameters of same data, count the data point, smallest, largest, second largest. I mean, sometimes you can understand your data only if you've got, corresponding statistics available, right? I mean, it is very much important when you say that you have to distribute, say for example, benefit income support program card to all the people in Nasser, in my hometown. The first question will come to your mind: how many people are there? So you need to count the data point, right? The one with the lowest income, the one with the highest income. I mean, all these numbers are very much important. That is the reason why you should have ability to get all these parameters from the data. It's mean, median, quantile, mode, all these things we have covered in detail. So you must know all these. Range, variance, standard deviation. I mean, these things are very important to understand your data. Uh, when you see standard deviation, you immediately come to know how dispersed the population is. If deviation is too low, you can say most of the people are having same income level. But if variation is too high, you know that if standard deviation is too high, you know that there are probably people who are extremely rich and those who are extremely poor, right? So this type of interpretation to the data can be given only if you have all these statistical parameter accessible to you, right? And then correlation and covariance. I mean, lot of statistical problems are solved only by by correlation and covariance. You want to see that if one variable is dependent to other, you just see their correlation. I mean, if both of them are varying together, their correlation must be very strong. But if both of them are not varying together, their inverse correlation will be very strong, right? And a correlation of 0 means they are totally independent, right? So these things we covered because these are very important in data science. And as I've been telling you, these things are not new, which we covered in our class. You have already seen those in your basic, states and probability courses. We did all these things programmatically as well, and then we also covered Simpson paradox, a basic example of correlation and causation. I mean, it is very important. I mean, the cause and effect thing. We covered this thing. This was the class assignment. So after these basic states, we then came to probability. Right, we discussed about random experiment, we discussed about sample space, we discussed about events. We did a lot of examples in probability, a lot of examples, just to understand the basics of probability. Because in later stage, we were using all these terms. These all things, I know that they were not new for you. So we very quickly went through all these. Complements, all these things we covered. The probability rule of complement, 1 minus probability of A is actually probability of A complement, right? Intersection, you know what is intersection. I don't need to again cover this basic thing. Mutually exclusive event, union of the event, right? All these things we covered. Additive rule of probability. Then couple of examples of this additive rule. Conditional probability, most important, I mean, because it is the building block or Bayes theorem. So that is the reason why it is important to understand conditional probability, right? I mean, conditional probability is actually probability of an event given another event has already taken place. And that's the whole philosophy of Bayes theorem. Conditional probability. Conditional probability actually comes into equation if both the events are dependent. I mean, if events are independent, then obviously conditional probability does not apply. I mean, how about if I say if there is rain today, then my age will increase by 1 day. Come on, even if it is raining or not, I will be older to myself 1 day than yesterday. So increase in my age by 1 day is certainly independent whether it is raining today or not. If it is rain today or if it does not rain today, my age will be 1 day plus what I was yesterday. So certainly these two events are independent, raining and increase in my age. So such type of event, there you must not apply conditional probability. There you must not apply Bayes theorem, right? So independent events, we have also discussed these. Lot of examples. So you must be practicing all these examples. As I have been repeatedly telling you that this exam will not be programming based. It will not be open book. I do not want you guys to write your English writing, which external may not be able to understand. I just want you to write numbers. So that is the reason why any part of this course, which is mathematical, statistical, or probability based, you must practice. Do a lot of practice. If you do a lot of practice, then exam, I might say 3-hour exam, but you should be able to complete it in 1.5 hours. And then remaining 1.5 hours, you should be reviewing it. And then believe me, I have also passed complete key to the external, and that's about, I think, 15-16 page long Microsoft Word document. So your external also have got the key. So remember, he will be comparing your answers with what I have done on the Microsoft Word document. So it is important that you do it same way as I have done. And if external is very rigid, he might only score you if your answers are correct. But if your method is okay and answer is incorrect, and if that guy is very lazy, then he might not give you good score. So that is the reason why I'm saying you should do a lot of practice, because if you do a lot of practice, then that 3-hour exam you should be able to complete in 90 minutes, and remaining 90 minutes you should, you know, check it. You should give it a second thought. You should check each and every small calculation. You must have calculator with you, because if you have calculator and if you have already completed your exam of 180 minutes in 90 minutes, then remaining 90 minutes you should be verifying all your calculations. uh, I mean, if you can do that, then you know, uh, your 50 out of 50 are also possible. But if you do not do a lot of practice, because that final exam will be mathematic intensive, uh, I guarantee you in 180 minutes you cannot complete it if you do not have a lot of practice. I mean, rest assured, when you cover any topic first time, you will get a sense that I am clear on that. I have understood it. You might have understood it, but you still need to do a lot of practice. Because if you do a lot of practice, only then you can be successful at such exams. So all these things you can see, these are mathematical. These are not theoretical. So I will be giving you different problems, and you need to give solutions. So you can see most of these topics which we have covered, they are mathematical by nature. So after this probability, we actually, if you see the course outline, linear algebra, states, probability, right? Then we had first mid exam, right? And then we came to deep learning. I mean, post mid one, everything was deep learning. So we started deep learning from here, introduction to deep learning, right? We discussed about chatbots, about self-driving cars, about virtual assistants, IP address to each and every living thing, uh, drama, TV script, you know, text generation you have already seen. So writing TV or drama script is also now a doable thing for our robots, right? And music composition, I mean, text generation is actually sequence generation. So if you can generate text, you can also generate music, right? So you can compose a very synthetic music which might be comparable with what A.R. Rahman is doing for Bollywood, right? So overall, you know, robots are killing our jobs. So we should feel scared. I mean, only computer scientists should not feel scared, because we people will be busy in developing robots, but those robots will be killing jobs for others. So whole, you know, ecosystem will collapse if we people are not preparing properly. That's what, you know, this AI literature suggests. Right. So deep learning is huge revolution. Yes.
I read somewhere that to understand our requirements correctly to the robot, clients need to specify requirements correctly. So our job is very safe.
That's right. That's right. I mean, that's what I'm saying, that few jobs are safe, but many jobs are not safe. I mean, you can already see in past we had typewriting guys, typewriters, huh? Their jobs completely wiped out with the advent of you know, computers, with the advent of word processing softwares. So you can see that many jobs that we saw in past, they were completely wiped out. How about, you know, bulls who are working in the field? I mean, their jobs has more or less died because of the invention of the tractor. So, you know, lots of jobs which we saw in our childhood, they are no more here. For example, in our childhood, we saw that we used to have people who produce, you know, Pakistani fridge, the matko. Now those guys have lost their jobs because we have now, you know, fridge and refrigerator. Because of these things, those uh, those matkas are no more there. And I know a lot of, you know, kumbhar who changed their profession because they knew that these things are out of fashion. Now In homes, you hardly see matkas. You see fridge, refrigerator. So obviously, a lot of jobs we have seen even in our life, they were wiped out. So and probably that speed was very slow. But because the advent of AI, that speed of wiping out jobs will be very fast. I mean, today we have got data entry operator, DEU. Huh? This data entry operator will also be redundant because now we can process images very well. So you just give that image to your scanner and automatically data will be entered. So obviously data entry operator, which previously probably for entering data of 100,000 records, we probably needed 10 people, but now we need just one guy who do all this scanning process, right? So certainly with the advancement of AI, we can see a lot of jobs are dying. I mean, as Harari points out, in 2050, almost 90% of the things that we are doing today will be doing it differently. Probably robots will be doing it at our place. I think Harari at one place he says the only job which will be safe is taking care of kids. So he says probably in future human will only be paid for growing their own kids because there you need emotions and these robots are not emotional. They are data based. They are not based on emotion. So obviously he says the only job which is safe is the job of growing your own kids. So he said one of the solutions to save this ecosystem is to give money to people just to raise their kids because everything else will be automated. I mean, a labor working in field, army working on the borders, all these will be your robots. You don't need human beings to do all these old style works. So certainly in 2050 things will be different, and those will be driven by two important technologies. One is deep learning, other is reinforcement learning. When I say deep learning, I'm referring to machine learning. So machine learning and reinforcement learning, these two things certainly will change many ways. I mean, the self-driving cars are also based on deep learning and reinforcement learning. So obviously, I mean, you can see here, deep learning is part of machine learning, which is part of AI. You know what was the classic programming? You give rules and data, they will give you answer. But here you give answer and data, they will give you rules. Machine learning. Machine is learning the rules. Huh? I mean, we people have grown up because we have learned the rules. We know that if somebody says, I am son of Y, and another guy also says, I am son of Y, then we know that both of them are siblings. Now, they never told us that they are siblings, but we knew the rule. If two guys are having same parent, then they must be siblings. We learned that rule. So recently we have actually given this capability to machine. That machine can learn rule, and it can learn rule from data and answers. In machine learning, this is a typical support vector machine thing. Then in deep learning, we discussed about layered approach. We discussed about what deep is in deep learning and neural network. I mean, those same old 90s hero, they actually made a comeback. We discussed about this MNIST. We actually implemented it. We said how layers are working. We discussed about weights, loss function, optimizer, a lot of other things. Okay, so we have today with us Anas. Anas, can you explain this picture to us? Anas, over to you. Just explain this, what this picture is saying. Anas Javed, are you?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Go ahead and explain this.
सर इसके अंदर हमारे पास हमने मतलब डिफरेंट बिट्स के ऊपर हमने इनपुट डाटा को हमने ट्रेन किया. उसके बाद ये जोन सा हमारे पास ये साइकिल आ रही है, लेयर डाटा ट्रांसफॉर्मेशन, नेक्स्ट लेयर डाटा ट्रांसफॉर्मेशन, उसके बाद फिर प्रिडिक्शंस हैं और फिर 2 टारगेट्स है, और फिर जो हमारा लॉस फंक्शन होगा फिर से इसको हम अपडेट करेंगे। अगर हमारे पास एक्यूरेसी वगैरह जो है वो ठीक नहीं आ रही है तो फिर हम दोबारा वेट्स जो से हैं मतलब इसके कम या ज़्यादा करेंगे, फिर ऑप्टिमाइज़र, फिर दोबारा यही साइकिल सर इस तरह चलता रहेगा जब तक हमारे पास एक्यूरेसी ठीक नहीं आ जाएगी।
आपने इतना क्विकली समझाया, आपको लगता है कि कोई अगर नए बंदे को आप ये समझाएं तो जिस तरह से आपने समझाया तो समझ में आ जाएगा?
पता नहीं।
पता नहीं। नूर, कैन यू एक्सप्लेन इट?
यस सर, आवाज आ रही है सर मेरी?
यस यस, वी कैन हियर यू।
सर एक्चुअली इट इज़ अ कंप्लीट डीप लर्निंग प्रोसेस। इसमें हमारे पास दो चीज़ें एज ए इनपुट होती हैं, जिसमें हमारे पास एक तो एक्स होगा और दूसरा उसके साथ हम इनिशियल वेट्स असाइन करेंगे जो कि शुरू में रैंडम हो सकते हैं। फिर हम लेयर्स डिफाइन करते हैं, मल्टीपल लेयर्स हो सकती हैं डीप लर्निंग के अंदर जो कि न्यूरल नेटवर्क की लेयर्स होंगी। उसमें 2 लेयर हो सकती हैं, 3 लेयर्स हो सकती हैं और मल्टीपल लेयर्स हो सकती हैं जो कि उसके ऊपर कुछ ऑपरेशन परफॉर्म करेंगी, जो कि बेसिक अगर उसको अंडरस्टैंड किया जाए तो वो हमारे पास इक्वेशन बनती है स्लोप की y इज इक्वल टू mx प्लस c और b, जिसमें हमारे पास जो हमारे पास x जो है हमारे पास इनपुट होता है और m जो है वो वेट्स होते हैं या w हमारे पास वेट्स होते हैं, और इस तरह से जो c होता है उसको हम b भी कह सकते हैं। वो हमारे पास सर एग्जैक्ट मुझे टर्म वो याद नहीं है, वो क्या टर्म थी सर? बी
बयास।
बयास, हाँ सर बयास, वो बयास होता है। तो इस तरह से ये हमारे पास हर लेयर पे कंप्यूटेशन होंगी इस चीज़ की, और ये कंप्यूटेशन होते वक्त होने के बाद हमारे पास एंड में जो प्रिडिक्शन आएगी उसको हम चेक करेंगे कि वेदर हमारे पास वो प्रिडिक्शन वो ट्रू है या नहीं है। उसका हम लॉस फंक्शन चेक करेंगे कि वो ओरिजिनल टारगेट से कितना हमारे पास दूर है, और स्लोप ग्रेडियंट से हम चेक करेंगे। तो अगर हमारे पास लॉस फंक्शन ज़्यादा है, लॉस फंक्शन से हम उसका लॉस स्कोर क्रिएट करेंगे, उसमें हम वो कंप्यूट करेंगे लॉस स्कोर जो आएगा, फिर हम उसकी बेसिस पे चेक करेंगे कि क्या हमें जो हमारे पास वेट्स हैं उनको किस तरह से अपडेट करना है। तो उसके बाद हमारे पास वो जो लास्ट स्कोर होगा वो ऑप्टिमाइजर के अंदर जाएगा, और फिर हम उनके जो हाइपर पैरामीटर्स होंगे उनको ट्यून करके जो वेट्स वगैरह हैं उनको हम एडजस्ट करेंगे, और नेक्स्ट टाइम पे वो हमारे पास इस तरह से ये पूरा प्रोसेस दोबारा से होगा, और इस तरह से हमारे पास लॉस कम होता 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 हमारे पास मिनिमम लॉस हमारे पास आ जाएगा।
Excellent, excellent. I mean, you've explained it very well, Noor. Okay, it's nothing. Just we have got input X and we have got Y. We predict with random weights. If that prediction is far from actual Y, we calculate the difference. That's the loss function, right? Then we optimize. It means that we update weights. So we just try that X with the X, we should get Y. But you know, this is a prediction. If this is too far from this Y, we repeat the process. So that's whole deep learning. Very simple idea, but obviously it has brought a lot of revolution in the field of machine learning. And it has been able to achieve human level, you know, accuracy in image classification, in speech recognition, in handwriting transcription, and it has improved machine translation. A lot of wonders it has already done. Text to speech conversion, digital assistants such as Google now and Amazon Alexa, right? Human level accuracy in autonomous driving, improved aid targeting as used by Google, Baidu, and Bing, improved search result on web, ability to answer natural language questions, and superhuman Go playing, right? So you can see this deep learning has already made a lot of progress, but they say do not hype. Otherwise, you will again be facing a lot of embarrassment as we faced in 60s, and then again in 90s. It is still at the supplemental stage. We are saying because even today, a lot of our aspects are not using AI. Huh? For example, uh, when I do hand washing in kitchen, I mean dishwashing in kitchen, I do not use any AI. I'm doing it everything manually, and sometimes I get lot of negative feedback from my wife. This is not clean. Do it again. So a lot of things that we are doing at home, they are all not AI based. That is the reason why we say it is still at the supplementary stage. It has still not taken central role in our lives, especially in third world countries. Yes, in developed countries like America, like in Europe, AI is being more in action. But in our context, we are yet to see, upside down change, which is expected because of artificial intelligence. I mean, we people have not still completely digitized a lot of aspect of our daily working. So obviously AI is probably the next step. So we say that in our context, even in developed countries context, AI is still at the supplemental stage, right? A transition has yet to take place. I mean, to come at the center of our lives, the way we think, the way we work, and the way we live. Presently, we are doing a lot of things manually. Then we discussed about history of machine learning. Uh, we discussed how neural network came back into fashion, right? Modern landscape of machine learning. I said that you must be visiting Kaggle very frequently, see what new data sets are coming. Uh, you know, we also discussed about the hardware requirement for deep learning. Then we also discussed about Google's Colab, and in fact, we have been using Colab very extensively in our course. And then we implemented this MNIST. We did not only implemented MNIST, but we also, fully understood it. We discussed basics of, TensorFlow. We discovered what are the tensors, how to do slicing on the tensors. All these things we have covered practically. Real world tensor example, vector data, time series data, images, videos, right? All these examples we have covered. You should be able to understand these. What are 1D, 2D, 3D, 4D, and 5D tensors? We have discussed those, right? And then we also had quiz at the end of this lecture. So first we had introduction to deep learning, and then we had introduction to neural network, because neural network is the most important component in deep learning. In fact, deep learning is nothing, just neural network. Huh? They call it deep learning because it sounds very fancy. Otherwise, deep learning is nothing, just neural network, right? So in the neural network, we discussed what is the slope equation. We mathematically understood this idea. We discussed about ReLU and other activation functions, right? We saw how aid, broadcasting, all these operations are performed in neural network on matrices, because matrices are important. Right? So these dot tensor dot product, dot of two vectors, we discussed all these. Reshaping of tensor, again we understood this whole block diagram. And then we discussed about these three type of neural network. And as we are in last class of this course, we know that we have covered fully connected, we have covered RNN, we have covered LSTM, and we have also covered CNN, right? We kind of agreed that we'll be covering these three, and when we end the course today, we know that all these three are clear on us, right? Cross entropy, categorical, MSE, all these things are clear on you. MSE we usually use for regression purpose, right? uh, important. I mean, TensorFlow is probably the most popular, library for deep learning. Keras is next to it, but Keras is nothing, just a wrapper on TensorFlow. I mean, backend we are still using TensorFlow, but Keras actually makes many things very easy. I mean, had we been doing it in TensorFlow, it would have been much difficult. I mean, in 2018, we covered deep learning course by using TensorFlow. That was a nightmare because a lot of complex things were there in TensorFlow. So those complexities have actually been made easier with the Keras. So even with the at the back end of Keras, TensorFlow is working, right? We understood this architecture. Uh, these are the basics of Keras. So I mean, just 4 steps. Define your training data. I mean, if you are going to approach any problem from the deep learning perspective, define your training data, input tensor and target tensor, your X and Y. Define a network of layer, a model that maps input to your target. The big questions are how many layers, how many neuron in a layer. We have answered this question many times. It has to be experimental. You have to start very humble and then gradually increase complexity. And if your performance is improving, you continue increasing the network storage, right? The architecture of network. But there will be one point when you will see that network is overfitting. Probably at that stage, you will understand that model has got a lot of memory. So we have to kind of deprive network from memory so that it does not overfit. So, you always need to cross that border between overfitting and underfitting, and you have to kind of stay on that border. That is the line between overfitting and underfitting. And we cannot, realize that border. We cannot see that border unless we cross it. So that is the reason why they say when you're doing any deep learning problem, you need to first overfit and then, just see where is that line and stay there. Configure the learning process by choosing loss function optimizer and some, metrics to monitor like accuracy or loss, and then iterate on your training data by collecting fit method. Simple, huh? Setting up deep learning machine, we saw how to do it on local machine, Anaconda, Python, Keras. We have seen that, and on Google Colab, everything is already pre-configured. So you just go there, log in, and run your code. We implemented IMDb, 25K training, 25K test. We saw how fully connected performs on IMDb. We also saw it on Reuters, having 46 class label, at least 10 file for each topic, and we saw how fully connected performs on that, right? And then, I mean, we saw the basics of neural network. The book is not covering mathematics, but I knew that you people won't be making a lot of sense of deep learning unless you know what is happening behind the scene. So behind the scene, it is all about this equation, mx plus b, the slope equation. So I started from here. I start from very, very basics. The slope thing, change in y, change in x, a couple of examples of slope. We understood secant and tangent lines, right? Uh, Examples of slope, right? And then we slowly, gradually reached to, this equation, which is actually the derivative, right? Which is actually the derivative. So we understood this equation. Then we saw some important, derivative rules. The most important one is this chain rule. The most important one is this chain rule. The most important one is this chain rule. When we understood this, you actually understand a gradient descent, right? And then we also saw this example. You can see, this is a typically a fully connected neural network, right? We understood this whole analogy. We understood how it is implemented in Keras, and then, we did one example. I mean, what is happening at one neuron, how z is calculated, again slope equation. The only difference is when slope equation, this x, w, and b are variable, but when we are doing it in deep learning, these are not variable, these are matrices, right? So we actually understood that what is the Z, what is happening at each single neuron, and then the activation function. And that activation function can be ReLU, sigmoid, or softmax, whichever you want, but R10H, that actually Z quantity is given here, and we apply the activation function. So this is what each neuron is doing. When you see this whole neural network, each of these neuron is actually doing nothing, is actually doing, this simple calculation. And after that calculation, it actually applies some activation function, right? So this is the Z at layer L. So we get weights from previous layer, we get activation from the previous layer, and then plus bias from the previous layer. So that actually is whole Z, and the activation for this layer is actually on this Z, we apply an activation function, right? So if you want to calculate, for layer 2, neuron 1, so layer 2, neuron 1 is this one. This is layer 1, this is layer 2, right? So on layer 2, neuron 1 is actually this one. It is equal to weights from neuron 1 into activation of neuron, neuron 1 from the previous layer, activation from the previous layer. This is the layer value, and this is the neuron value. So the activation from previous layer, and plus B1. So that will be something at Z1, then at Z2, then Z3, Z4, Z5, Z6, all these 6 neurons, they will do their calculation, and this is their corresponding activation. So we need to understand how calculation is performed at each of these neurons. These are actually simple, these all of them are actually matrices. All of them are column matrices, right? This one and this one, and then plus B is also a column matrix. Except this activation, on W, this B1 is actually the column matrix. And we also understood what are the dimension. When you see the next slide, you can see the dimension. The dimension for W is actually the number of neuron in previous layer and number of neuron in current layer. This is the row, this is the column, right? But V is actually a column matrix. So we understood all these dimensions, we understood these calculations, and then we saw what is backpropagation, right? Backpropagation is actually updating weight. So weight for layer L equal to weight for layer L, the previous value, minus this learning rate and the derivative of W. So with the example, we actually understood it, right? And same way we also update the bias, right? So we saw this beautiful picture. When you give X, you calculate values for layer 0, then for layer 1, then for layer 2, up to for the last layer. And that last layer is actually equal to predicted Y. So when you have got predicted Y, you compare it with actual target. That is your loss function. It will give you some value. Then you actually do, derivative of Y with respect to A at L, then L minus 1. At every step, you can see we are updating, the previous weights. At every step, we are updating previous weights. And then we again come back with the new weights to calculate new Y. And this process actually continues, until we are improving the performance, right? And then, in order to better understand neural network, we saw this simple example. I strongly recommend you do this with paper pencil. You understand it with different weights, right? Here, I chose these weights and only 2 neuron here and 3 layer. But I strongly recommend that you do it with a different architecture, maybe 3 or 4 or 5 neuron at 1 layer, 5 neuron at 2nd layer, 5 neuron at 3rd layer. Assign weights randomly and then see all these calculations. The net at H1, what is that? And then net at H1, and then apply activation, which actually gives you output at H1. So output at H1 is actually activation of net at H1. So activation of net at H1, which means the sigmoid in this case, right? It is sigmoid in this case. So sigmoid is actually 1 over 1 plus e power minus x. Here x is net of H1. So here we say it is actually 1 over 1 plus e power the net of H1, which is 0.3775. So that we keep here. So we get this output at H1, right? So if these are the weights, if these are the biases, the output that we get with these random weights with this input is actually 0.593, right? And you also need to understand the problem. We say when we give 0.05 and 0.10 as input, the output should be 0.01 and 0.99. So these are the actual output, right? So in order to estimate output at O1 and O2, we need to estimate output at H1 and H2, right? Because the input to O1 is coming from H1. So before estimating O1, we need to calculate H1. So we are calculating output at H1, and that is nothing, just the slope equation and then activation of that slope equation, right? So we get this value, which is the output at H1. Then we calculate output at H2, right? Then we calculate output at O1 and O2. All these values, I strongly recommend that you do these with the different architecture, maybe 3, 4, 5, 6, 7 neuron at each layer, random weights, do all these calculations. So all these formulas are on your fingertips. If these formulas are on your fingertips, then you can do this quickly. Otherwise, I'm not sure that you people can solve it properly. Then you need to understand how to estimate error, right? So error at O1 is actually equal to the square of the difference between target and the predicted output, right? So we get that error total. So error total is actually error at O1 plus error at O2. So at O1, we were expecting 0.01, right? We are expecting 0.01, but we got 0.75. So the error here is 0.27, and error at O2, we were expecting 0.99, but if you see at the output 2, we got 0.77. So we expected 0.99, but we saw 0.77. So 0.77 minus 0.99 square is actually error at neuron 2. So when you sum these two, you get total error. Right. Now this total error is non-zero, which means that we need to update the weights. Right. We update the weight by doing, this derivative of error total with respect to W5 by applying the chain rule. Right. So we apply chain rule. We estimate the quantities. We do all these derivatives. You should be able to understand these. I've done this on board in class. So all these things, we calculate new weights, and we do this, one pass of updating all these 6 weights, W1, 2, 3, and 4. Right, and then we also saw this. After 10,000 times, we said the predictions will be very correct. Right, so we have seen this complete example, which actually decodes whole neural network, which actually gives us a feeling what actually neural network is doing behind the scene. Yes, we have implemented them in Python, but unless you see the mathematics behind this, you won't be able to understand what deep learning is. Right, so this was our introduction to neural network. And then mathematical building blocks of neural network, data representation neural network, the gears, all these things. Getting started, introduction to Keras, classifying newswire, the concept of regression, housing price, fundamental of machine learning. This was the full example. Machine learning. This one, this is the chapter number 4, I believe, which actually explains everything in machine learning. Supervised, unsupervised, self-supervised, reinforcement. All these things you might have already covered in your data mining course as well, but we discussed them again in a lot of detail. Training, validation, test, you understood it, right? Cross validation, the k-fold validation, all these things. You need to be careful about the arrow of time, redundancy in your data. You know, all these things we have covered in a lot of detail. Then we discussed about regularization, the process of fighting with overfitting, right? We discussed about dropout. We discussed about L1 and L2, right? So all these things we discussed in regularization. I hope those are clear on you. When you do dropout, you are actually disabling some of the neurons in different layer just to reduce memory of the network. How to do it programmatically? We add a layer of dropout. You already seen it, right? All these examples we did practically, and this level is also important. They say when you have got binary classification, you should be having last layer activation as sigmoid. When multi-class, apply softmax. When multi-class, multi-level, sigmoid. When regression, you don't need to, because in regression you actually report MAC, the actual number of the error, right? But if you want to convert regression problem into classification, to convert 0 and 1, then it becomes a binary classification, right? So there you have again sigmoid. Add layer, make layers bigger, training for more ripples. We usually do these to, you know, first overfit and then see what is the optimal value for all these things. Apply regularization. Then we discussed about deep learning for computer vision. We discussed about CNN, very efficient. This is the architecture of CNN. I think we are very much clear on that. Then we discussed about ImageNet, right? It achieved 98% accuracy on 1000 classes. CNN, we discussed about filter size, stride, padding. This is this, you know, formula for convolution. Apparently it looks a very difficult formula, but when you see it, it's actually nothing like this thing. You've got image, you've got filter. So 2 into 2 plus 3 into 3 plus 1 into 2 plus 1 into 3 plus 2 into 1 plus 3 into 4 plus 2 into 1 plus 4 into 5 plus 1 into 3, that becomes 57, right? And then you actually stride it by 1. When you stride it by 1, you just move it once to the right, right? So again, you know, 2 into 3, 3 into 2, 1 into 1, and so on. So that becomes 63. Now you cannot stride on right because you have already reached to the end. So then you actually stride it down and left. So you actually kind of start from here: 3, 1, 4, 1, 5, 3, 2, 4, 1. So you can see the next stride is here. Again, same filter, right? So 2 into 3 plus 3 into 1 plus 1 into 4 plus 1 into 1 plus 2 into 5, 3 into 3, 2 into 2, 4 into 4, 1 into 1, right? So that becomes 54. Convolution with a stride, I mean, that was the with a stride 1, but this one is stride 2. So you can see we start from here, but then we stride by 2, 1, 2. So next time it is here, right? So you can see when we go down again, stride by 2. So 1 and 2. So we come here, right? So this was the convolution operation, convolution with padding. Subhan, you have to turn off your mic. Okay.
Sorry, sir. Sorry.
Thank you. Thank you. Okay. So max pooling, you are clear with max pooling as well. Very simple. You do not need any value here. You just need to explain filter size and see what is the maximum value in that size. Take that value. So in this filter, you can see 5 is max. So 5 is here. Here again, you can see 6 is max. So 6 is here. Straight down, so you can see 5 is max. So 5 is here. So that's max pooling, right? We also have got, you know, max pooling with the stride, and then average pooling. You just take average in the filter, right? And then that actually goes to fully connected layer. convo, pooling, and then fully connected, right? So, you know, just to see exactly what is happening, you are kind of taking one piece at a time from the image. So obviously the mathematics that happens behind the scene is kind of taking, taking a record of what is in this part of the image, what is in this part of the image. So certainly if it is 4, then these patterns will be matching with each other. If you are comparing 10 images, each of them having 4. But if some of them having 4, some of them having 3, so certainly these subparts will be very different, right? We understood this analogy of Kate, and then we applied it on MNIST, and we saw that around 68% of the error was removed only when we used MNIST and replaced it with fully connected. When we replaced fully connected with the ConvoNet, we saw that 68% of the error has been reduced. And then this one is also very much important. ConvoNet from scratch and small data sets. Cat versus dog. Cat versus dog. We saw this one. Okay, so then after this, I think the next one was concluding CNN. CNN and then starting text processing. The next one was concluding CNN, and I also discussed that what will be the revised impact on assessment because of COVID. So training a convolution from scratch and small data sets, we covered it. We covered augmentation. We covered pre-trained convolution like VGG. We saw all these concepts, very, very beautiful concept. Exception, inception, ResNet, VGG, all these things we discussed. We reached 96% of accuracy on cat versus dog, right? All these things we have already seen. I also gave you assignment on Cypher. And then we came to text classification. We discussed about document classification, the BBC assignment, topic modeling, time series comparison, sequence to sequence. I mean, certainly it is the data science course. So we did not go in depth of deep learning, but those who are interested, I strongly recommend them to further explore, sequence to sequence, like, translation from English to Sindhi. So certainly these are very exciting topics that you can choose for your future, right? And then class project discussion. I hope you are working on that. I'll be discussing class project in the end of this lecture. So working with text data, tokenization, vectorization, all these concepts we have discussed in detail, implemented them programmatically. We discussed about embedding layer, how to aid an embedding layer. All these videos are also available, so you can watch them again using pre-trained word embedding like GLOVE. You must have seen it, you must have used it. This class exercise, those who have done this class exercise, they know that how pre-trained or embedding layer are different. And then we discussed about RNN. Then we discussed about RNN. So when we came to RNN, we discussed about sequence translation, right? We discussed what is RNN. We discussed this equation of RNN, implemented it in Keras, right? And then, we also not only understood the equation, but we covered a mathematical example of RNN. That is very much important. You can see a class assignment LSTM. After RNN, we covered LSTM. And then we also covered applying convolutional neural network on text. There is one lecture where we covered RNN and LSTM. Okay, RNN, the mathematical example, this one. Why? I think it should start from here. Yes, this example is also important. We saw how RNN is working. So if your data is HELL, we want to see what is the next character, right? So randomly initialize WXH, randomly initialize, this is the bias, and this is, I think, WHH, right? And then you see all these calculations. I mean, you actually estimate these two quantities. The first quantity, when you've got some input, you want to calculate current state. So current state is actually sum of these two quantities. So you already have input. For the first character, you do not have previous input, so you will take all 0. For the next state, the current output is the previous state, right? So previous state, and this one we will generate randomly. This we generate randomly. This is the input, and this is coming from the previous state, right? So you actually estimate this quantity, you estimate this quantity, you sum both of them and apply 10H on them. So it will give you H3, which becomes H3 minus 1 when you are at H3 plus 1, right? And then you calculate Y3, which is nothing, just H3, another random matrix, another random matrix. So you estimate these two quantities, sum them, calculate 10H, and then that is H3, which is used to estimate Y3. And if you see block diagram, I mean, it is not necessary that each step you take an output, and in some stages you can even ignore the output. If you see the block diagram of RNN, the unfolded block diagram, yeah, this one, right? So you can see at each step we are taking output, but in some cases you may not consider output. You may ignore it. You are only interested in final output. For example, if you say what is after HELL, so after H, what is output, you are not concerned. You just give that as an input to the next step. So you give here H, then E, then L, then L, and here when you see the output, you are only concerned with that final output, right? Because the structure of RNN is such that at each stage you will get output. Obviously, their output is used as an input to the next stage as a H3, but you also have that as a connection to the output. So it is up to you whether you are processing that output or not. In some cases, you might be interested at the output at each stage. In other cases, you'll be interested for the output at the final stage. So here, if you want to predict what is after HELL, then you should not see what is after H. You should not see what is after E. You should not see what is after L. You should not see what is after L. But you should only see what is after L here, right? Because you're interested, the network should predict O. If you give them HELL, the network should predict O. If network is not predicting O, then you do back propagation, right? So this structure actually gives you proper understanding when and when you should and when you should not be interested in the output, right? So we saw this happening. We did all these calculations. We understood this mathematical example of RNN fully, applying softmax, and then estimating error in RNN is actually the predicted Y and into log of actual Y, right? And when you've got multiple outputs, you do this, a sum of all the errors, right? And then you do same gradient the way you do in neural network in fully connected. So RNN, we saw how RNN is implemented in Keras, and then we applied it on a couple of data sets. A lot of experiments. This was the example of RNN in Keras. We understood this in Python notebook. How to stack multiple RNN, multiple layers of RNN. You can see we have seen that RNN on IMDb. We saw this one. Then LSTM, right? The only difference is this extra connection, the carry connection, and that carry connection is having this simple formula, right? LSTM with IMDb, and then I gave you a class assignment, pre-trained GitHub with LSTM, advanced use of RNN, recurrent dropout, stacking RNN, and bidirectional. We have also seen all these. We understood this, and applying convolute on text sequences. That was the last topic in classification. Right.
सर
I think, yes.
सर यही है कि हमने जो है ना RNN यूज किया है या LSTM यूज कर रहे हैं, अगर हम उनको प्रेडिक्शन करवाना चाहते हैं, जैसे कि हम इमेज प्रेडिक्ट करवाते हैं ना, कोई भी एक रैंडम इमेज देखे तो इमेज क्लासिफिकेशन वो इजीली बता रहा था कि ये नंबर है। लेकिन जब ये प्रेडिक्शन करवा रहे हैं तो वो एक सीक्वेंस दे रहे हैं। अब उस सीक्वेंस को हम कैसे टेक्स्ट में करें और फिर उसको कैसे बताएं कि ये वो किस लेवल से मीन्स मैच कर रहा है, तो ये एक क्वेश्चन था हमारा।
Can you say it again, Malik? I think you're now discussing about text generation or what?
सर टेक्स्ट जनरेशन हो, ये यही सिंपल हम एक टेक्स्ट क्लासिफिकेशन कर रहे हैं सिंपल LSTM के थ्रू। ठीक है सर, हमारा मीन्स पूरा इपोक वगैरह चला लिया, ट्रेनिंग कर लिए, इवोल्यूट भी कर लिया, एक्यूरेसी भी अच्छी दे रहा है। लेकिन जब हम प्रेडिक्ट की बात करते हैं, एक रैंडम उठाते हैं, नेट से उठाते हैं या कहीं से और से उठाते हैं और उसको डिटेक्ट करवाना चाहते हैं कि ये क्या दे रहा है, लेकिन वो प्रेडिक्ट में रिजल्ट्स में सीक्वेंसेस दे रहा होता है और उनकी प्रोबेबिलिटी दे रहा होता है।
आपका क्वेश्चन क्या है? व्हाट इज योर क्वेश्चन?
सर जो जब हम LSTM यूज कर रहे हैं तो हम रैंडम टेक्स्ट उठाएं और उसको प्रेडिक्ट करें किस लेवल के साथ वो कनेक्ट हो रहा है और वो लेवल का नाम बताएं। सिंपल ये क्वेश्चन है, वो कैसे होगा?
You mean text generation or what?
सर टेक्स्ट क्लासिफिकेशन सिंपल, नॉट टेक्स्ट जनरेशन।
यस को थोड़ा अगर एग्जांपल के साथ एक्सप्लेन करें। मालिक, मैं अपनी शेयर स्क्रीन स्टॉप कर रहा हूँ, अपनी स्क्रीन शेयर करके एग्जांपल के साथ थोड़ा समझाएं।
सर ये मालिक कहना चाह रहे हैं कि हमने ट्रेन कर लिया है एक मॉडल को, अब उस पे प्रेडिक्शन कैसे करें, कि प्रेडिक्शन करने के बाद उसकी लेवल कैसे बताएं।
सर ये मतलब मैं आपको एग्जांपल दे देता हूँ, जैसे कि ईमेल क्लासिफिकेशन होती है ना सर, ईमेल स्पैम क्लासिफिकेशन। हमने एक मॉडल बना लिया कि वो डिटेक्ट करे कि ये ईमेल स्पैम है या स्पैम नहीं है, ठीक है। अब हमने एक टेक्स्ट उठाना है और प्रेडिक्ट करवाना है मॉडल से कि जो है ना ये स्पैम है या हैम है, तो वो कैसे होगा सर?
कम ऑन यार, वो तो देखा ना,
प्रेडिक्ट से हो जाएगा ना सर।
अगर आप देखे मालिक, let me explain it to you. Colab, okay, Colab.
Please share me screen along so that I can show you what I want to say.
Okay, नहीं मैं समझ गया हूँ। अभी थोड़ा मैं अपनी स्क्रीन शेयर कर रहा हूँ। मालिक देखें
सर, वो मालिक के पास एक एग्जांपल है स्क्रीन पे सर, वो उसका थोड़ा देख लें, वो समझ नहीं आ रहा हमें।
चले, मैं इसको अपनी स्क्रीन स्टॉप कर रहा हूँ और मैं अलाउ कर रहा हूँ मल्टीपल पार्टिसिपेंट। यू कैन शेयर योर स्क्रीन नाउ। Malik, you can ask the question. Malik, your mic is off. Malik.
जी सर।
हाँ
सर एक मिनट में, सर मैं ये कहना चाहता हूँ कि मैंने एक डेटा सेट उठाया हुआ है ईमेल का। ठीक है सर, उसमें जो डेटा सेट है ना वो स्पैम है और नहीं है, वो 0 और 1 की लेबलिंग में पूरा डेटा सेट है। डेटा सेट जो टेक्स्ट है ना उसका बहुत सिंपल, मेरे पास क्या है, एक जो है ना पूरा टेक्स्ट है और मैं इनकी क्लासिफिकेशन करवाना चाहता हूँ स्पैम है या नहीं। तो मैंने पूरा मॉडल बनाया है और उसको वेक्टर पे प्री ट्रेन कर रहा था, लेकिन वो एरर दे रहा है। फिर मैंने क्या किया, LSTM पे किया खुद 32 पे, और मैं उसको सिग्माइट दे रहा हूँ। बाइनरी क्लासिफिकेशन है क्योंकि हमारे पास आंसर 1 है, 0 और 1 में देगा, तो प्रेडिक्शन है वो 90% 50% से ज्यादा है तो 1 देगा। तो सिंपल ये सारा सर कोड चल रहा है। सिंपल मैंने इवैल्यूएट भी करवा लिया, उसने एक्यूरेसी भी अच्छी दे दी है। लेकिन जब मैं प्रेडिक्शन की बात कर रहा हूँ तो डॉट प्रेडिक्ट, मॉडल डॉट प्रेडिक्ट होता है, तो रिजल्ट्स में वो मुझे दे रहा है सीक्वेंसेस और सीक्वेंसेस की प्रेडिक्शन दे रहा है। तो उसको मैं कैसे लेबल के साथ मीन्स अटैच करूंगा कि ये मेरी किस लेबल के साथ ये जाके मीन्स प्रेडिक्ट कर रहा है। तो प्रेडिक्शन जब मैं करता हूँ ना, तो वो मुझे देता है सीक्वेंसेस ऑफ द मैट्रिक्स, और जिसमें वो प्रोबेबिलिटीज की वैल्यूज दे रहा होता है हर एक सीक्वेंस की। सर मैं यही
आप एक काम करें ना, आपने आपने वो कहाँ किया है, जो आपका प्रिडिक्ट मेथड कॉल कहाँ किया है, वो दिखाए ना।
सर यहीं पे आपके सामने नीचे कर रहा हूँ।
मतलब आवाज आपकी कम हो गई है, मुझे बताया। हाँ, अभी जो मॉडल है ना, यू सी रिजल्ट इक्वल टू मॉडल डॉट प्रिडिक्ट, मॉडल डॉट प्रिडिक्ट, मॉडल
यहाँ
डॉट
पे मैं
मॉडल डॉट प्रिडिक्ट, इसको आप दे रहे हैं x
33,
टेस्ट 33। यस,
लेकिन जब मैं
यार
रिजल्ट को प्रिंट
मालिक योर माइक इज वेरी,
अब मैं रिजल्ट को कॉल कर रहा हूँ।
हाँ बिल्कुल
तो
सही
ये
है।
रिजल्ट्स जब मुझे रिजल्ट दे रहा है ना, तो वो सीक्वेंसेस की मैट्रिक्स दे रहा है, मींस उनकी प्रोबेबिलिटीज दे रहा है।
सही
क्योंकि
है।
मैंने
ओके,
ये पहले सेल से रन करो ना, वो पहला सेल रन नहीं हो रहा माउंटिंग वाला, इसलिए नीचे नहीं आ रहा।
नहीं वो हो चुका है, ये थोड़ा वो सर ये
मैं समझ गया आपका इशू, बिल्कुल मैं समझ गया।
मैं इसको खत्म कर देता हूँ एक मिनट सर। अगर मैं चलो यहाँ से इवैल्यूएट के बजाय यहाँ पे इवैल्यूएट कर रहा है ना, तो मैं यहाँ इवैल्यूएट की जगह प्रेडिक्ट कर देता हूँ ना, क्योंकि मुझे सीक्वेंस में कन्वर्ट करना चाहिए पूरा डेटा सेट।
बिल्कुल सही। नाउ यू नो व्हाट यू नीड टू डू, यू नीड
जी
टू सी के प्रोबेबिलिटी किस क्लास की हाईएस्ट है ना, जिस भी क्लास की
सर वो
प्रोबेबिलिटी,
प्रोबेबिलिटी स्कोर जो दे रहा है ना, वो प्रोबेबिलिटी में एरे दे रहा है पूरा।
बिल्कुल एरे देगा, फिर उसमें से आप मैक्स उठाएंगे। मैं
सर
आपको,
मैक्स में,
हाँ
मैक्स में भी वो फिर मसला कर रहा है।
नहीं मैं आपको समझा रहा हूँ, ये आपको मैं पूरा एक्सप्लेन कर रहा हूँ। ये
मैं स्क्रीन स्टॉप कर दूं अगर आप बोले तो
हाँ
सर।
हाँ हाँ, आप स्क्रीन स्टॉप कर ले, मैं आपका प्रॉब्लम समझ गया। ये असल में
जी
ये
सर।
यही करेगा, आपको प्रोबेबिलिटीज देगा ना, जितनी भी क्लासेस है हर एक क्लास की प्रोबेबिलिटी बताएगा ना। तो
सर
आप
मेरे पास 2 क्लासेस हैं, लेकिन वो प्रोबेबिलिटी दे रहा है पूरी सीक्वेंसेस की।
मैं आपका एक मिनट में आपको थोड़ा ये एक्सप्लेन कर लूँ, फिर जो है ना ये आपके प्रॉब्लम
ठीक है सर, आप शेयर कर दें स्क्रीन। और
मैं आपको ये समझा रहा हूँ कि ये होगा कैसे ना। Let me open a code segment, result.evaluate, print results, but classifier B. Okay, not this. MNIST sentiment 140 cat versus dog by LSTM. Prepare just transformer classification fast text. Okay, let me. Yes, I think here it is. Model dot predict x text predict classes. Okay, okay. Then you accuracy score. Okay. See here. I hope you can see my screen. Eh? Can you see my screen?
Yes, sir.
Okay. So, Malik, once if you have trained your model the way I have done it here, you do predict classes. You pass X test, right? Now this X test, first you have to prepare it. If it is text, you need to convert it into vectors. And how to do that? I think you have already seen this. You do this, and not this, but actually vectorization. This example we have already seen. So you take that, you fit on text tokenization and generate sequences from text to sequences, right? So this process you have to follow. You will have to convert it into your X test. So in this case, I split my data from train and test, right? And train and test. When you split data, this is your X train, this is your X test, Y train and Y test. You first prepare your data. You have to vectorize it. This process we have already covered so many times. Once if your model has been trained, the next step that you need to do is to, you know, do this. See here, I say on my model, predict class for this test. And तांजे केस में आपके केस में आप क्या करेंगे कि आपका ये जो ईमेल्स है ना, ये जो ईमेल्स है आपकी, उनको आपको कन्वर्ट करना है सीक्वेंसेस में, और वो सीक्वेंस पास करनी है इस वाले मेथड को जो मॉडल के अंदर है, predict classes. ये आपको देगा लेबल, ये आपको देगा लेबल, ठीक है, और वो लेबल होगा या 0 या 1, ठीक है. अच्छा, वो आप लेबल पास करेंगे इस वाले मेथड को. numpy में आपका एक argmax है, तो फिर इसको आपको राउंडेड कर देना है ताकि पता चले कि लेबल क्या मिले हैं, लेबल क्या मिले हैं. अच्छा, अब ये आपको काइंड ऑफ एक कॉलम दे देगा ना, ये इस तरह से एक कॉलम दे देगा. मैं अगर एक्सेल चलाऊं तो ये आपको ना इस तरह से एक कॉलम दे देगा. आपने इसको राउंड कर लिया है, आपने इसको राउंड कर लिया है? अच्छा, अब ये थोड़ा
सर इनके बाइनरी क्लासिफिकेशन है.
हाँ, भले बाइनरी क्लासिफिकेशन हो, लेकिन ये देगा आपको प्रोबेबिलिटी ना. अच्छा, अब
सर
होगा
वो
क्या,
कॉलम देगा या 2 वैल्यूज देगा बस 0 और 1
ये आपको इस तरह से देगा. फॉर एग्जांपल, अगर आपने इसको 10 ईमेलें दी हैं, तो पहली ईमेल की जो प्रोबेबिलिटी है ना, आपको रिटर्न वो इस तरह से करेगा 0.63, जो आपको क्लासीफायर रिटर्न करेगा ना 0.63 एंड 0.37, ये आपको रिटर्न करेगा ना. ये कहेगा कि 0 की प्रोबेबिलिटी 0.63 और 1 की प्रोबेबिलिटी 0.37. मैं यहाँ पर क्या कर रहा हूँ, मैं कह रहा हूँ कि argmax, यानी कि वाई टेस्ट में जो मैक्स है ना वो मुझे निकाल के दो. तो मैक्स कौन सा है, 0.63 है ना, तो ये 0.63 मुझे उठा के दे देगा. उसको ये राउंड भी कर देगा, तो ये आखिर में मुझे राउंड होके मिलेगा. तो ये जाहिर है 0.63 था ना, इसको जब ये राउंड करेगा तो ये 1 कर लेगा, ये 1 कर लेगा. तो इसी तरीके से ये जो आपका पूरा समझिए वाई टेस्ट में सपोज कि आपके पास 10 लेबल थे, तो उन सारे 10 लेबल में जो मैक्स स्कोर है ना वो उठाएगा, उसको राउंड कर देगा. तो जाहिर है एंड ऑफ द डे आपको मिलेगा क्या, इस तरह से, माना 0 0, हो सकता है कि 1 1 1, ये फिर 0 फिर 0, फिर ये 1 फिर ये 1, आपको इस तरह से लेबल मिल जाएंगे ना. जब ये आपको लेबल मिल गए, अब आपके राउंडेड लेबल में वो लेबल पड़े हुए जो आपने प्रेडिक्ट किए हैं. अब अगर आप एक्यूरेसी देखना चाहते हैं कि एक्यूरेसी मुझे क्या मिली है, तो आपको जाहिर है इन लेबल को कंपेयर करना है एक्चुअल लेबल से. तो ये एक्चुअल लेबल है, y well predict and the rounded label are the actual label. You are comparing both of them. Accuracy score एक आपका मेथड है, इसके अंदर है साइकिट के अंदर, इसके लैंड मैट्राइस नो इसके अंदर नहीं है मेरे ख्याल में.
सर मैंने इसको पहले यूज किया है.
हाँ ना,
सही है सर,
ये आपको ये दोनों चीजें आपने जब इसको पास कर ली, इनको कंपेयर
ठीक है
करके
सर. ठीक
आपको
सर, ये वही क्लास है जो आपने हमें पहले फास्ट टेक्स्ट शेयर कर चुके हैं सर शायद.
बिल्कुल बिल्कुल बिल्कुल.
ठीक है सर, थैंक यू
समझिए
सर.
ना, तो ये
जी
आपको
सर.
पूरा प्रोसेस करना है. अब आप इस एक टेस्ट में एक ईमेल भी दे सकते हैं, 1000 ईमेल भी दे सकते हैं. ये
ओके
आपको
सर,
जो
ओके.
argmax है ना, ये आपको ये सारा प्रॉब्लम सॉल्व करके दे देगा.
ठीक है सर,
ठीक
ठीक
है
है.
ना.
थैंक यू सर, थैंक यू सर.
ग्रेट ग्रेट. ओके, सो वी वर हियर, हम कहाँ थे, हम थे यहाँ पर. ठीक है. सो फंडामेंटल मशीन लर्निंग के लिए ग्रुप प्रोजेक्ट्स का डिस्कशन हो गया था. RNN, LSTM, GRU, ये सारी चीजें क्लियर हो गई. उसके बाद जाहिर है मैंने इसमें टेक्स्ट जनरेशन नहीं लिखी हुई है, क्योंकि टेक्स्ट जनरेशन मैंने आपको सिखा के उसको असेस भी कर लिया है विद दैट असाइनमेंट. तो दैट इज द रीजन व्हाई मैंने वो इसमें नहीं डाली है कि अननेसेसरी आपका जो एक्सटर्नल है वो इसमें से कोई अपना थोड़ा एफिशिएंसी दिखा के क्वेश्चन ना निकाल ले. तो मैंने वो यहाँ पे आउटलाइन में वो इंक्लूड नहीं किए. तो टेक्स्ट जनरेशन आपके फाइनल एग्जाम में शामिल नहीं होगी, क्योंकि उसको मैं असेस कर चुका हूँ, मैंने आपको असाइनमेंट उसके ऊपर दे दी है. अच्छा, ये जो प्रोजेक्ट्स हैं ये भी हम थ्रू आउट कोर्स हम ये कर चुके हैं, माना ट्वीट क्लासिफिकेशन विद LSTM हम कर चुके हैं, ट्वीट क्लासिफिकेशन विद LSTM एंड प्री ट्रेन्ड वर्ड एम्बेडिंग ये भी आप कर चुके हैं, और इमेजेस की क्लासिफिकेशन विद CNN ये भी आप कर चुके हैं ना। अब मेरे ख्याल में इस कोर्स के कंक्लूजन पे हम इतने तो कैपेबल हो गए हैं कि हम टेक्स्ट को प्रोसेस कर सकें और हम इमेज को प्रोसेस कर सकें, राइट। अगर ये दो चीजें हम कर सकते हैं तो काफी सारे प्रोजेक्ट्स हैं जो कि आप लोग बना सकते हो, काफी रियल वर्ल्ड के इश्यूज है जिनको आप सॉल्व कर सकते हो, सिंपली इसका इज द लिमिट है। अच्छा, अब अगर अब तक कोई आपको क्वेश्चन हो तो आप पूछें।
सर एक क्वेश्चन मेरा सीधा अपनी असाइनमेंट के तरफ था कि जब हम ट्वीट्स लेबल वो जो ट्विटर वाला ग्लव यूज कर रहे हैं स्पेशली, तो क्या वो हमें रिजल्ट में वेक्टर दे रहा है या वर्ड्स दे रहा है? क्योंकि हम जो सीक्वेंसेस पढ़ी हुई है जनरेशन वो हमने पढ़ी है वेक्टर, सिर्फ करेक्टर बाय करेक्टर सीक्वेंस जनरेशन जो आपने क्लास में भी एग्जांपल कराई थी सर। तो उसके साथ जब मैं ग्लव कनेक्ट कर रहा हूँ तो वो मसला कर रहा है, एरर दे रहा है।
आप ग्लव क्यों कनेक्ट करेंगे इसके साथ?
सर आपकी वो हमें असाइनमेंट में कहा गया है ना, आप LMS पे आ जाए ना।
एक मिनट मैं थोड़ा असाइनमेंट ओपन कर लूं।
जी सर।
असेसमेंट मिड 1 क्लास फाइनल एग्जाम, ये मैं खोल लूं आपको दिखा दूं फाइनल एग्जाम?
सर प्लीज।
कोई मसला ही नहीं होगा सर, ये दोनों की भी भेज दें सर साथ
है?
में, की भी साथ में भेज दें, इतनी मसला नहीं होगी।
हाँ ना, की भी साथ में भेज देता हूँ, बिल्कुल यार। असाइनमेंट थी, असाइनमेंट क्लास
सर दुआएं देंगे आपको।
हाँ हाँ बिल्कुल बिल्कुल। मिड 1
वो
एग्जाम
LMS पे आ जाए ना, तो वहाँ पे लास्ट असाइनमेंट है हमारी ये वाली।
यार वो हिते तो रखी हुई है ना, आखिर में हिते तो रखी हुई नहीं, ये की होना मिड 1 न्यू
सर
फोल्डर।
LSTM के टेक्स्ट जनरेशन की है वो, शायद आपने यहाँ पे रखी है या नहीं रखी, नहीं रखी है।
हेलो भला LMS से डालना, ओके 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 LMS ये सबमिशन जी डेडलाइन तक गुजरी वही है।
हाँ सर वो गुजरी वही है, सिर्फ तव्हांजे जेको न इश्यूज हुआ उहे इश्यूज ही पुछणा, तव्हांजे वालिद साहब जी डेथ थी वई उनजे करे पोइ असां इश्यूज, हालांकि जेको न मैसेज टाइम ते न करे सघियासीं छाकाणि तव्हां बिज़ी हूंदव, पर इन शइ जे करे असां चयो आहे न, चयोसीं हाणे सर रिलैक्स थिए, नेक्स्ट क्लास में चुको इहा डिस्कस करे वठंदासीं।
दीदी तव्हां वॾो थोरो आहे, तव्हां मूंखे टाइम ॾिनो रिकवर करण जे लाइ।
सर मां मैसेज करे चुको आहियां तव्हांखे, हालांकि इश्यूज वग़ैरह मां तव्हांखे मैसेज कयो WhatsApp ते, तव्हां उन्ही जो बि रिप्लाई कोन कयो।
अच्छा हाँ हलो यार ठीक है। ओके सो
सर
डेडलाइन
हिन जा 2-3 ॾींहं ॾेई छॾियो सर।
December 24 ही डेडलाइन है। अच्छा, डाउनलोड ट्वीट इमोशन डेटा सेट। ओके, the data set is highly imbalanced and mixable and train an LSTM based model with GitHub Twitter word embedding on 90% of the data. The report accuracy and model simple है, इनमें छा है पहिरीं त इहो ई आहे, पोइ इहा ट्रेंड ॾाढो सिंपल आहे यार, ॾाढो सिंपल आहे त माना ही
गिलव ते क्यों था उहो मसलो करे थो, ॿियो कुझु न आहे।
छा थो मसलो करे?
तव्हां हिते लिखियो आहे, हिते तव्हां लिखियो न ट्रेन द LSTM सेपरेट ईच क्लास जनरेट, ऐं इहो जेको ट्रेन करणो आहे न उहो गिलव ते करणो आहे,
हाँ
मसलो गिलव वारो करे थो, ॿियो कुझु ई न आहे।
माना
गिलव ट्विटर आहे न।
इहो त सफ़ा ईज़ी आहे, हीअ ॾिसो न, माना आउं तव्हांखे हिकिड़ो मिनट ॿियो, let me show you colab classifier B GitHub Twitter ही है ना, this is GitHub Twitter GitHub, there are two GitHub, one is GitHub which is on Wikipedia, second is
जी सर,
GitHub which is on Twitter. So
असां
because
बि
we are
ट्विटर यूज़
using
करूं था सर।
because we are working with tweets, so it's good to use GitHub Twitter rather than GitHub. So I think in this code I have this GitHub Twitter. It should be, this is bird.
सर चओ त मां स्क्रीन शेयर करे छॾां, किथे एरर ॾे थो छा करे थो उहो
Sentiment 140 by LSTM, sentiment 140 by LSTM. classifier C, classifier C mau do mane kan me GitHub Twitter. It should be is jo tanjo e data set bird tokenizer bird is jo bird hai acha ye bird hai okay kape to GitHub not this sentiment 140 with GitHub sentiment 140 with GitHub okay this whole example here GitHub Twitter so you do nothing you have this simple method create embedding matrix right you pass it file path word index and embedding dimension vocab size is equal to word index this one which you are passing plus 1 embedding matrix is equal to initially you create a matrix of 0 with vocab size right vocab size is this one and embedding dimension you open the file which you have downloaded this one the
सर
GitHub
इहा
file
बिल्कुलु असां रीड करे चुका आहियूं हर शइ कयो आहे सिर्फ़ु एरर इहो आहे कि जॾहिं असां इन खे LSTM ते हो कयूं था असां कयो आहे करेक्टर बाय करेक्टर ठीकु आहे सर माना जेको असां माना प्रेडिक्ट कंदो अॻियों करेक्टर कंदा पियूं छाकाणि असां पढ़ियो बि करेक्टर बाय करेक्टर आहे वर्ड बाय वर्ड जेको GitHub ट्विटर आहे इन ते जंहिं टाइम असां ट्रेन कयूं था इहो आहे वर्ड बाय वर्ड इन में वर्ड्स न ई के करेक्टर्स
न तव्हां सही असाइनमेंट खे सम्झो कोन्हे हाणे तव्हां थोड़ो एक्सप्लेन तो करें असाइनमेंट के ना तव्हां
ठीक है
पहिरीं छा कंदो देखें सबसे पहले आप क्या करेंगे आपको फिलहाल टेक्स्ट जनरेशन को भूल जाना है ना
अच्छा
सबसे
सर
पहले ये डाउनलोड करवाना है ठीक है पड़ा हुआ है वहां पर दिस इज
जी
हाईली
सर
बैलेंस्ड सबसे पहले आपको ट्रेन करना है LSTM को ऑन GitHub ट्विटर
जी
90% डेटा को यूज करना है ट्रेनिंग के लिए 10% डेटा को यूज करना है टेस्ट के लिए जनरेशन को
ओके
फिलहाल भूल जाए एक्यूरेसी बताएं ठीक है अच्छा फिर
जी
क्या
सर
करना है फिर करना है ट्रेन LSTM मॉडल सेपरेटली फॉर ईच क्लास लेवल एंड जनरेट इनफ सैंपल फॉर ई नाउ वी आर टॉकिंग अबाउट टेक्स्ट जनरेशन अच्छा हाँ टेक्स्ट जनरेशन का भी मैंने आपको ना पूरा वो दे दिया है ना कोड अगर आप
जी सर
देखें तो उसमें हमने पहले ट्रेन किया था उसके ऊपर जो नावल था उसका है ना फिलोसोफर का
जी जी जी
तो अब
जी
बजाय वो नावल का टेक्स्ट आपको नहीं लेना है उस टेक्स्ट को आपको रिप्लेस कर लेना है पहले इस लेवल के
सर
टेक्स्ट के ऊपर
इसमें हम जॉय के जो भी रिव्यूज होंगे उन सबको रीड करेंगे और फिर जनरेट करेंगे उसको
बिल्कुल
एक टेक्स्ट बना के फिर रीड करेंगे ओके सर
बिल्कुल
थैंक
बिल्कुल आपको
जी सर
समझेंगे कैरेक्टर के ऊपर क्लासिफिकेशन करनी नहीं है ये दो टास्क है समझे
ओके
एक ही टास्क के
ओके
अंदर दो टास्क है पहला अप टू दिस
यही सर
पॉइंट हाँ
दोनों
आप
की वजह से हालांकि हमने
हाँ
ट्राई बहुत किए एरर्स आ रहे थे फिर अब भी
you don't need आप आपने थोड़ा इसको अंडरस्टैंड गलत किया है अप टू दिस
जी सर
पॉइंट टेक्स्ट जनरेशन को आप भूल जाए कुछ भी नहीं करना है
ओके
LST विद GitHub ट्विटर कोड आपके पास है आपको सिर्फ इसके ऊपर अप्लाई करना है ये जो है ना इस वाले डेटा सेट के ऊपर
सर
कोई ना कोई
इसमें
आप
एक और क्वेश्चन था कि काफी ऐसे भी हैं जो ब्लैंक्स हैं जो आए लेबल दे रहे हैं लेकिन ब्लैंक्स है तो मैंने उनको रिमूव कर दिया है
बिल्कुल सही है ये जो प्री प्रोसेसिंग है ना ये आपको करनी चाहिए
हाँ
प्री प्रोसेसिंग आपको करनी चाहिए सो दैट्स गुड
जी
दैट्स गुड दैट्स गुड
थैंक यू सर थैंक यू
ठीक है हेलो वालेकुम सर सर क्या हाल है ठीक है Okay, so I hope assignment is clear, है मालिक?
जी सर अभी क्लियर है सर अब 3 दिन और देते हैं और हम आपको सबमिट करते हैं
चले मैं आपको 3 दिन और दे देता हूँ ओके ओके दिसंबर जैन ओके जैन जैन 3 जैन 3 2021 okay okay so this Jan 15 remind me to grade ठीक है 2021 Okay, that's it. ठीक है, 3rd of Jan 11:59 is the deadline for submitting this assignment.
थैंक यू सर, थैंक यू।
7 data. चले, so आई होप कि ये सारी चीजें आपके ऊपर क्लियर हो गई हैं। आपके प्रोजेक्ट की सबमिशन डेडलाइन क्या है?
सर आपने रखा भी नहीं है
नहीं वैसे
वो सिर्फ
नहीं, जो ब्रीफ डॉक्यूमेंट है उसमें तो मैंने लिखा हुआ है ना
सर। उसके लिए थोड़ा हमें टाइम ज़्यादा दें सर हमें।
प्रोजेक्ट।
सबमिशन ये थी और या
हाँ सर, आइडिया उसके बाद वो आपने क्रिएट भी नहीं किया,
नहीं
तो
क्रिएट
वही
नहीं
देख रहे
किया,
थे कि कब सबमिट करना है।
लेकिन सबमिट कब करना है? December 3 must finish
यस
by
सर।
Jan 5. So Jan 5 is the deadline of submitting your project.
सर
Right.
जनवरी 10 कर दें सर प्लीज।
यस सर, हमारे हमारे एग्जाम यकम फेब से स्टार्ट हो रहे हैं, तो हमारे पास मंथ है, तो आप रिलैक्स करके डेट इसकी दे दें। हमें ब्लॉकचेन का भी सर ने पूरा मंथ दिया है प्रोजेक्ट असाइनमेंट्स वगैरह के लिए, तो हम रिलैक्स होके कर लेंगे सर अच्छे से।
क्या कह रहे हैं
सर मैं कह रहा हूँ कि मतलब
को ना
हमारे एग्जाम जो से हैं वो हमारे एग्जाम यकम फरवरी से स्टार्ट हो रहे हैं, तो अभी पूरा मंथ पड़ा हुआ है, तो हमें थोड़ा रिलैक्सेशन देकर डेट इसकी एक्सटेंड कर दें प्रोजेक्ट की, सेमेस्टर प्रोजेक्ट की, तो हम अच्छे से कर लेंगे इसको।
अच्छा, थैंक यू माधु, थैंक यू बेटा, थैंक यू थैंक यू थैंक यू। यार ये अनफेयर है, Jan 5 मैंने कहा था और Jan 5 में अभी भी 5-6 दिन हैं, और आपको
ये
पता
सर
है
वो
क्या
आपकी बात ठीक है।
काम तो उन्हीं, असल में मसला पता है क्या है? मसला ये कि IBA ने हमें कहा है कि 10 जनवरी से पहले आपको ना 60% बच्चों का अपलोड कर लेना है, क्योंकि 11 जनवरी से बच्चों के एग्जाम है, तो जिनको विड्रा करना है तो वो ना विड्रा का डिसीजन उनके पास हो। तो हमारे ऊपर ये एक डंडा है कि आपको 10th of Jan से पहले 60% बल्कि 50%, क्योंकि फाइनल 50% है, तो 50% का मुझे अपलोड कर लेना है ना, तो इस वजह से मैं 2-3 दिन तो बढ़ा सकता हूँ, लेकिन ज्यादा नहीं बढ़ा पाऊंगा ना।
8 कर दें
तो
सर
हमारे
आप।
ब्लॉकचेन वाले टीचर ने पूरा मंथ दिया हमें।
भाई
यार
उसको
वो
छोड़ो सर, 8 कर दें आप, 3 दिन और कर देते हैं बस, ज्यादा नहीं।
मैं 8 भी नहीं कर रहा हूँ, मैं 10 जनवरी कर रहा हूँ। 10 जनवरी
बस
तक
सही है
आपको
सर, ओके ओके ओके
कर
ओके।
लेना है, और
इंशाल्लाह सर, इंशाल्लाह।
बाय दैट
ओके
टाइम
सर।
लिंक वहाँ आ जाएगा ना।
सर एक और चीज के आप फाइनल की भी लिब्रिक्स दे दें, क्योंकि ये तो आपने आइडिया सबमिशन के लिब्रिक्स दिए थे ना, तो
नहीं इसमें
फाइनल
है
असेसमेंट
इसका,
कैसे होगी?
नहीं उसी उसी के अंदर रूब्रिक वो भी लगा हुआ है, ये देखें नीचे इसका दूसरा रूब्रिक है, ये देखें।
अच्छा
हाँ ये प्रोजेक्ट फाइनल असेसमेंट, इसका रूब्रिक यहाँ लगा हुआ पूरा, सही है ना।
ठीक है, थैंक यू सर,
तो
सही है सर।
5% ऑफ द कोर्स है रिपोर्ट के ऊपर, एंड 5% है आपके वीडियो के ऊपर ना, बिकॉज योर
ठीक है,
वीडियो विल बी नाउ पार्ट ऑफ द फाइनल प्रेजेंटेशन। ठीक है,
ठीक है सर, थैंक यू सर,
हाँ ओके
थैंक्स अ लॉट।
ओके।
अल्लाह हाफिज़।
Any other question? Any other question that you might have related to course?
सर मैंने थोड़ी जो मेरा सेमेस्टर प्रोजेक्ट है उसके बारे में थोड़ी डिस्कशन करनी थी।
हाँ पूछे पूछे।
अगर आप सर जो मैंने प्रोजेक्ट उठाया था ना सर, मैंने डिटेक्ट करवा रहा था लाइंस होती है ना, जो रोड के ऊपर लाइंस होती हैं ऑटोनोमस व्हीकल को चलने के लिए, जो साइड्स पे 2 लाइंस होती हैं, मैंने उनको डिटेक्ट करवाने के लिए ना, तो मैंने सर जो कंप्यूटर विजन है ना, सिंपल टेक्निक्स, उससे तो सर मैंने उसको किया हुआ है। वो तो मतलब सिंपल टेक्निक्स होती हैं कि मतलब हम उसको यूज़ करके ओपन सी वगैरह की टेक्निक्स यूज़ करके हम उसको डिटेक्ट करवा लेते हैं लाइंस को ना, और फिर हम उसको वीडियोस भी वो पाइपलाइंस वगैरह बना के और वीडियोस भी पास करवा के पूरी वीडियोस में भी लाइंस को हम डिटेक्ट करवा लेते हैं। लेकिन सर मैं इसको डीप लर्निंग के ज़रिए करना चाह रहा था, और अगर मैं डीप लर्निंग के ज़रिए करता हूँ तो मेरे पास सर इसकी डोमेन फिक्स है, मतलब जिसके अंदर मैंने अपनी कार को चलानी है वो मेरे पास डोमेन फिक्स है, तो मुझे वहाँ से मैंने वीडियोस को रिकॉर्ड करना है, वीडियोस को उस मतलब उस डोमेन के अंदर ना कैमरा लगा के मैंने वीडियोस को रिकॉर्ड करना है, मतलब उन लाइंस की वीडियोस को ना, तो फिर उन उन वीडियोस को मैं फ्रेम्स में ब्रेक करूँगा, फिर उसको सर फिर उसका मैंने डाटा सेट बनाना है, फिर उसको मैंने लेबलिंग करनी है, और फिर सर उसके ऊपर मैंने मॉडल को ट्रेन करवाना है। तो सर मुझे मेन मसला आ रहा है कि मैं इसको लेबलिंग किस तरह करूँ, और मतलब फिर आगे थोड़ा सा अगर आपको कुछ अंदाज़ा है तो।
या देखिए ना, आपको करना ये चाहिए कि वीडियो में से ना आप स्नैप निकालें।
यस सर, बिल्कुल मैं यही करूँगा। इसके
हाँ,
बाद हमारे पास
हर
पिक्चर्स बन जाएंगी।
बिल्कुल हर एक सेकंड में से आप समझेंगे,
यस सर, यस सर।
क्योंकि वैसे तो सेकंड में हर एक सेकंड में 27 से 28 इमेजेस होंगे, क्योंकि फ्रेम पर सेकंड यूजुअली 25 to 30 होते हैं ना, तो
ठीक
समझिए
सर।
हर एक सेकंड के अंदर 25-26 इमेजेस होंगे। तो आप ज़्यादा नहीं करें क्योंकि चेंज इतनी एब्रप्ट नहीं होती है, तो आप एक सेकंड के ऊपर 3-4 इमेजेस लें, ठीक है।
ठीक
जब
है,
आपने
ठीक
एक
है।
सेकंड के ऊपर 3-4 इमेजेस ले लिए,
यस सर,
हो सकता है कि आपकी वीडियो मिसाल के तौर पे हो 5 मिनट की ना, अगर 5
यस
मिनट
सर।
की है तो आपके पास 1200-1300 के करीब समझिए कि आ जाएंगे इमेजेस। एक तरीका है उनको मैन्युअली लेबल करने का ना। मैन्युअली लेबल करना ज़ाहिर है एक बड़ा टीडियस टास्क है। आपको करना पड़ेगा मे बी 30-40% आप मैन्युअली लेबल कर लें, और फिर क्या करें कि कोई एक ऐसी यूटिलिटी बनाएं जो कि आप कह रहे हैं ना कि लाइन, तो वो लाइन को डिटेक्ट करवाएं। तो बाकी जो इमेजेस हैं उनको आप मैन्युअली लेबल ना करें, उनको आप कहें कि जहां जहां पर ये लाइन अपेयर हो रही है तो उनको एक लेबल दें, जहां लाइन अपेयर नहीं हो रही है उसको दूसरा लेबल दें। इसको हम सेमी ऑटोमेटेड कहते हैं, माना हम कह रहे हैं कि हमारे पास टोटल 1 लाख इंस्टेंसेस हैं, अब सबको हम मैन्युअली लेबल नहीं करना चाहते हैं, तो 30% को मैन्युअली लेबल करें और बाकी 70% को ना हम उसी मॉडल के ऊपर टेस्ट करवाएं। तो जहां जहां पर मॉडल बहुत ज्यादा कॉन्फिडेंट है, से फॉर एग्जांपल आपको कॉन्फिडेंस मिल रहा है, प्रोबेबिलिटी आपको मिल रही है 0.90, व्हिच मींस दैट मॉडल इज क्वाइट कॉन्फिडेंट कि इसका लेवल क्या है, तो वहां पर आप उनको फिर भले वो वाला मॉडल जो प्रेडिक्ट कर रहा है ना वो उसको लेबल दे दें। लेकिन अगर कहीं पर से फॉर एग्जांपल मॉडल प्रोबेबिलिटी दे रहा है 0.55 या 0.50, तो वहां पर मॉडल अनश्योर है कि इसका लेवल क्या होना चाहिए, उनको फिर आपको डिस्कार्ड कर देना चाहिए ना। ये एक टेक्निक है समझें कि सेमी ऑटो लेबलिंग की, जिसमें आप थोड़े से डेटा के ऊपर मॉडल को ट्रेन करके फिर मॉडल से ही बाकी अनलेबल को ना लेबल करवाते हैं। ये इस टेक्निक का नाम है, मैं भूल रहा हूँ, मेरे ख्याल में नाम मैं इसका भूल रहा हूँ, अभी रिसेंटली भी मैंने इसको पढ़ा है। इसको सेमी ऑटो लेबलिंग का प्रोसेस बोलते हैं, लेकिन इसका एक नाम भी है ना मशीन लर्निंग में, मैं इसको थोड़ा भी रिकॉल नहीं कर पा रहा हूँ। तो आपको ये करना चाहिए, इमेजेस कुछ लें, उनको आप मैन्युअली लेबल करें, क्लासीफायर बन जाएगा, उस क्लासीफायर से बाकी मानदा इमेजेस को आप लेबल करवाएं।
ठीक सर। अच्छा सर, मैं इसकी मतलब जो मैं इसको लेबल करूँगा तो हमारे पास जो मेरे पास इन्वायरमेंट है उसमें कुछ ट्रैक के ऊपर मतलब सीधी लाइंस हैं, कुछ पे टर्न्स वगैरह भी हैं, लेफ्ट राइट, और फिर उसकी जो सी इमेजेस भी आएंगी, मतलब एक बार हम मतलब क्लॉकवाइज ला रहे हैं, एक बार एंटी क्लॉकवाइज ला रहे हैं, तो मतलब वहाँ पे टर्न जो से आएंगे वो डिफरेंट आएंगे। तो सर फिर इन सब की क्लासेस वगैरह बनेंगी?
बिल्कुल बिल्कुल बिल्कुल, कुछ आपकी 4-5 क्लासेस बन रही हैं, कुछ को आपको मैन्युअली लेबल करना है, बाकी को आप ऑटो लेबल कर सकते हो।
ठीक सर।
सही है ना। चलें, एनी अदर क्वेश्चन रिलेटेड टू योर प्रोजेक्ट, और एक बात ध्यान में रख लें, जो भी आपने असाइनमेंटें जमा कराई हैं मैं उनको अभी चेक करने के प्रोसेस में हूँ, इंशाल्लाह ताला बिफोर जनवरी 5 मैं अपलोड कर लूँगा आपका जो रिजल्ट है, तो आप भले वो देख लें। सर अच्छा भले आई एम अबाउट टू फिनिश। अच्छा ठीक है ना। सो इफ यू हैव एनी अदर क्वेश्चन।
सर वो सर हम ये सोच रहे थे कि जो सी हमने असाइनमेंट सबमिट करवाई हैं, अगर आप उनमें से एक दो हमें यहीं ओपन करके थोड़ा डिस्कस कर देते तो जो हमारी मिस्टेक्स वगैरह हैं तो हमें पता लग जाती कि हमारे पास एक्यूरेसी क्यों कम आ रही थी, हम इसे और ज़्यादा
तो
इंक्रीज
मैं
किस तरह कर सकते थे।
असाइनमेंट चेक करूंगा ना, तो मैं आपको एलएमएस पे ही उसका फीडबैक भी दे दूंगा, जो भी असाइनमेंट
चलिए
में
सर,
चेक
ठीक है।
करूंगा उसका मैं फीडबैक भी आपको दूंगा।
ठीक सर। और
ठीक
सर
है?
जो आप कह रहे थे वो 3-4 डीप लर्निंग के प्रोजेक्ट हैं वो हम डिस्कस करेंगे, तो हम डिस्कस तो नहीं कर पाए सर, वो आप हमारे साथ शेयर कर देते हैं, हम खुद ही उसको देख
नहीं,
लेंगे।
वो हमने डिस्कस किए ना थ्रू आउट, अगर आप कोर्स आउटलाइन देखें, इफ यू सी द कोर्स आउटलाइन।
सर आपने कहा था नेक्स्ट क्लास में मैं अलग से 3-4
अब यार वो
प्रोजेक्ट
असल
लेके
में फिर
आऊँगा।
मैंने जब इसके ऊपर गौर किया आउटलाइन के ऊपर, तो मैंने कहा ये तो सारी चीजें हम कर चुके हैं ना। मेरे
ठीक
ख्याल
सर, ठीक सर।
में मोस्ट इम्पोर्टेंट है ये वाला जो मैं अभी खोल के बैठा हूँ ना, ये ट्वीट सेंटीमेंट 140। अब सेंटीमेंट 140 आपको पता है कि कौन सा डेटा सेट है, आपको पता है ना कौन सा है?
ये सेंटिमेंट्स एनालिसिस वाला होगा।
नहीं, इसमें टोटल इंस्टेंसेस कितने हैं?
सर ये वो है ना ट्वीट इमोशन वाला।
नहीं, ये अलग है। ये इसमें टोटल 1.4 मिलियन ट्वीट्स हैं, 700,000 पॉजिटिव, 700,000 नेगेटिव। तो इसको आप जब क्लासिफिकेशन इसके ऊपर करते हैं मुख्तलिफ, ये मैंने समझे कि LSTM विद गिलफ ट्विटर अप्लाई किया तो मुझे इसके ऊपर 82% एक्यूरेसी मिली। और वही प्रोसेस है जो कि हमने बाकियों के ऊपर अप्लाई किया हुआ है। ये मैं डेफिनेटली आपसे शेयर कर सकता हूँ। ये मेरा अभी रिसेंटली पेपर पब्लिश हुआ, उसमें उसके लिए हमने ये एक्सपेरिमेंट परफॉर्म किए थे, तो ये मैं आपसे शेयर कर लेता हूँ। इस बल्कि इस एक में ना मैंने सारे कोड किए हुए हैं। ये देखें ट्विटर सेंटीमेंट, ये सेंटीमेंट 140 वाला है। ये बाकी कॉलम मैंने इग्नोर किए हुए, सिर्फ सेंटीमेंट और कंटेंट्स वाला जो है ना कॉलम, उसके ऊपर मैं काम कर रहा हूँ। मैक्सिमम 40,000 वर्ड्स, 280 लेंथ, क्योंकि ट्विटर 280 का होता है। एम्बेडिंग डायमेंशन इज 100 बिकॉज गिलफ ट्विटर इज 100। ठीक है, देन टेस्ट साइज इज दिस सर्विस, राइट? So taste size 10% and 90% is training. Then I'm loading this at Twitter Glove, Glove Twitter. I'm loading it. This should be on your Google Drive. Otherwise, it will generate error. And then I'm creating whole LSTM the way we have been doing it, in our class many times. Once this is done, I'm just fitting, history. I'm fitting training data with the Y label for 10 epochs. I get around 82% accuracy. And the code that I shared today in response of Malik's question, that is also here. So what I'm going to do, I'm going to share this with you all. I'm sharing it with Malik. Malik, you can share it with others. Malik, are you there?
जी sir.
Okay, so you can share it with others, but this one example actually explains everything that we have covered so far. Pre-trained word embedding, LSTM, everything.
Okay, sir. Thank you, sir.
Okay, guys, so we are going to end class here. It's already 2 p.m. If you still have any queries, we all are connected on WhatsApp. You can also send me email, but this was the last class of this semester. Any question, we are always open on WhatsApp, or you can also send me an email, or you can also
Sir, this is the last class of our degree.
Oh my God. Are you sure, Subhan?
Not sure about data science.
सर मेरी एक और है, सुभान की शायद ये लास्ट हो।
क्या कह रहे मालिक? अच्छा, आपकी होगी एक और
सॉफ्टवेयर टेस्टिंग की क्लास है सर आज।
चले, ठीक है। चले यार, थैंक यू वेरी मच ऑल। सी यू फेस टू
सर लास्ट बट नॉट लीस्ट क्वेश्चन सर, वो 10% वाला मिड वाला था, तो उसकी इवोल्यूशन अब तो फाइनल उधर जा रहा है, तो हम बाकी 30% पे आप कर देना सर, रिक्वेस्ट है।
ये आपको थोड़ी और मेहनत से करना, हो सकता है मैं मान जाऊं, लेकिन मैं अभी नहीं मान रहा।
सर मेहनत
सर मेरी कोडिंग स्किल अच्छी है, मैं आपको मेहनत
चले यार, ये डिस्कशन हम फिर बाद में करेंगे। मेरे पास गेस्ट भी आ गए, तो
ठीक है सर, आप सर ज्वाइन कर लेंगे इसको। थैंक यू सर, थैंक यू, अल्लाह हाफिज़।
सी यू फेस टू फेस व्हेन यू कम ऑन कैंपस।
यस सर, इंशाल्लाह वी विल डिस्कस दिस टॉपिक ऑन देयर।
थैंक यू ऑल, थैंक यू, बाय बाय।
Thank you very much, sir.
अल्लाह हाफिज़ सर।
अल्लाह हाफिज़।
अल्लाह।